Thank you. Good afternoon. I'm going to talk about augmented reality hardware, and in particular, its key enabling element, which is transparent holographic display. And my immediate goal is to find partnership with an Air Force office so as to steer our F-Works phase 2 proposal towards specific platform and environment. And as part of this partnership, we will be seeking endorsement in the form of a customer memorandum. Next, please. In my definition, augmented reality comes in response to unsatiated desire to see more that meets our eyes. And augmented reality comes in two kind of big classes. It's HUD, head-up display, and near-to-eye display. HUD can be implemented on avionics platform. That could be fixed rotary wing aircraft, and its specific need for this HUD is on takeoff and landing, where the HUD would provide at minimum symbology on the landing, touchdown point, landing zone, etc. Similarly, it's on the left, you can see that's focus of my presentation. Similarly, HUD will perform kind of similar function on vehicle. Head-up near-to-eye displays include head-worn component. It could be also helmet-integrated display, where, for instance, for a bomb disposal suit, where you would put additional information, range to the explosive and other things that is required, increase situational awareness. It can also be integrated into a rifle scope, giving the sharpshooter target information as well as wind parameters, for instance. Since our school focus on avionics, we will be brief look at the market, which is, according to the study, is to reach 4 billion in 2022 for both civilian and commercial product. Next, please. Architecture, we call it Safe View, includes sensor suite, backbone, processor, content generator, and projector. As I said, our immediate call to fame is transparent holographic display, although our inspiration for the entire system. And the design of the system is to provide situational awareness without, so to say, taking eyes from the road, as well as reducing operator workload and stress. Next, please. Underlying technology HoloCore is a transparent hologram recorded on a flexible laminate. Oh, please go back. One slide back. Yes, thank you. Is transparent hologram recorded on a flexible laminatable film. Laminatable means it can put on glass surface. It also can be sandwiched between two glasses, and that's important for environmental stability. Glasses can be flat and curved due to flexibility of HoloCore, and that enables swap reduction and cost. Next, please. I should say HoloCore replace existing HUDs are based on optical HUDs. Please go back. Yeah, existing HUDs are optical HUDs, so they use optical components, and using hologram that combines in itself all these optical components allows the swap and the cost reduction. The key sort of beneficial features of this technology, it's we preserve the see-through property of the glass by reducing haze of the hologram and increasing transparency. We keep 90% transparency and above. We also maximize the information content by using RGB colors. So it's a full color hologram. Brightness is controlled due to high efficiency of the hologram, again, over 90% efficient. And important thing is we create out of plane image, which means that a pilot operator doesn't have to refocus eyes from the plane of the hologram to the far distance of the road or landing zone. The image is projected, so to say, virtual image over there. And that reduces fatigue and workload. Next, please.
30-second warning.
LGS is a mature startup, I would say. We have already 1 million in sales of holographic components, LSD, LSM, as you can see on the right. We are selling them to military aerospace primes. We have 1.6 million in SBIR won this year. We have demo program with OEM and major projector supplier. And we have a unique roll-to-roll process that permits high quality replication of these holograms. That's the key for commercialization. Next. Next, please. And what we are looking under the watchful eyes of our chief scientist, Dr. Dimov, that's our head-up display, head-worn display with the resolution chart that is shown on it. We are seeking for customer memorandum partnership with the Air Force organization to tailor our phase 2 proposal to actual environment. We also open, of course, to collaboration for other system integrations, for helmet, rifle scope, and we open to investment to accelerate time to market. Thank you.
Perfect. Thank you so much for presenting, Lev. Right now, we're going to open up the floor for questions for Lev. Feel free to kick it off. Dash, go ahead.
So the slide on the pilot view, my question is more related to when you don't have a pilot on board, how do we use, this is when it comes to autonomous unmanned vehicles, how do you think about the system helping in that case when there is no pilot to make that judgment? So this, so anything on that you have looked into?
Well, if there is no pilot either on board or somewhere else who would need to see, no, that's specifically designed for augmented reality. So you would like to see something with your eyes and all the additional information to it. It's not
so
just...
morely like, so if it's a remotely piloted aircraft and your line of sight, so when it's remotely piloted, the person is not really actually on board, but it's elsewhere. Does that have a limitation?
Well, one can imagine a situation for landing when you need to see the landing of the UAV and additional information. Yes, then it would be helpful to have augmented reality display. Yes.